Hello and welcome to the next lecture. In this lecture we will talk about couple of the loop functions in R. So let's jump right in it. So loop functions are some of the most powerful functions in the R language, and they make it kind of very easy to use, especially in an interactive setting. The idea behind a loop function is you want to execute a loop over an object or a set of objects in a way that does a lot of work in a very small amount of space. That way you don't have to type as much on the command line. Of course, we already learned about loops. We know about for loops and while loops, things like that, and those all work very well. However, they are less compact in a certain way. So there are a few loop functions in R, and they usually have the word apply in them somewhere. So some of the key ones are lapply, sapply, apply, tapply, and mapply. And the real workhorse function that I would like to talk about here is lapply. And the idea behind lapply is that you have a list of objects and you want to loop over the list of objects and apply a function to every element of that list. And so it's a very general concept, and it can be used very powerfully to do a lot of computations in just a little bit of typing. Sapply is a variant of lapply that simplifies the results. Apply is a function that operates over the margins of an array, so this is very useful if you want to take summaries of matrices or other high dimensional arrays. Tapply is short for table apply, and it applies a function over subsets of a vector. And mapply is a multivariate version of real lapply, so I will go into details about how these work in a minute. There's also another function called split, which doesn't actually apply anything to objects, but it's often useful in conjunction with functions like lapply or sapply because it splits objects into sub-pieces. So lapply takes 3 arguments. Basically, the first argument is a list which is called x. The second argument is a function or the name of a function, and then there are other arguments that can be passed to the dot argument. And the dot argument is used to pass arguments that go with the function that's being applied to each of the elements in the list. If x is not a list, then you must coerce it to a list if possible. If it's not possible to coerce the object to a list, then you will get an error. So the lapply function, as you can see, is very simple. The code for it is right here. Basically, first we look for the function, then if the object is not a list, then it's coerced to a list using as.list. And then the rest of the lapply function is implemented internally in C code to make it a little bit faster. So the idea with lapply is that you are going to take this list of things, and remember, a list can contain any number of different types of objects. So they could be vectors or matrices or data frames or whatever it may be, and you want to apply a function to each one of these elements of the list. And that function is going to return something. It may not be the same thing that it originally was on the list. So for example, it may take as an input a vector, but then it may return a scalar as a result. So the functions are going to return something for every single object in that list, and the return values are going to be assembled in a new list, and that's what lapply is going to return. So lapply, it's key to remember, it always returns a list. What goes in may or may not be a list, but it will be coerced to a list, and what comes out will always be a list. So here's a simple example. I am creating a list of 2 elements. The first one's called A, and its sequence from 1 to 5. The second one is called B, and it's 10 random variables. So and then what I want to do is I want to loop over this list of 2 elements and apply the main function to each of those elements. So you can see that when I call lapply on x and I apply the main function, I get another list back. And notice the list has the same names as the original list, A and B. But now I've got the mean of the first element and the mean of the second element. And so that's how lapply works. Here I've got a slightly more complicated list. Now I've got 4 elements and I'm calling lapply to each of those elements. And I'm getting the mean of each of those elements. So now I've got a list with 4 elements. The names are preserved, and notice here, of course, you know each of the elements of the original list was a vector or a numeric vector of some sort, but what I'm getting back is a vector with just a single number in it for each element of the list. So here's another way to call lapply. Here I'm creating a sequence of x 1 to 4 and I'm calling runif. which generates the uniform random variables using a random number generator. Now the first argument to runif is the number of uniform random variables that you want to generate. So if I say runif1, it's going to generate a single random variable. If I say runif2, it's going to generate a vector of 2 random variables. So here I'm applying the runif function to sequence 1, 2, 3, 4. So what I'm going to get is a list where the first element is a single random number, random uniform. The second element is going to be a vector of 2 random uniforms. The third element is going to be a vector of 3, and the fourth element is going to be a vector of 4 random uniforms. And so you will note here, if you know the runif function, you will know that it has other arguments to it beyond the number of uniforms to generate, but those other arguments have default values, so I don't need to specify them here. Now suppose I want to call the runif function on each one of these elements of x, but I didn't want to just generate a uniform between 0 and 1, which is default. Suppose I want to generate a uniform between 0 and 10, and so now I need to pass some arguments to the runif function which are not the default values. In particular, I need to change the max value, so I can do that through with lapply by passing these arguments through the dot argument. So here I'm calling lapply. On x I'm calling the runif. I am passing the runif function, but also I am specifying that I want the min to be 0 and the max to be 10. So now when I run this, I get out the list that has random uniforms that are between 0 and 10. So lapply and the associated functions make heavy use of what called anonymous functions. Anonymous functions are functions that don't have names, so you don't assign them a name of some sort, but you can kind of generate them on the fly. So here is a just quick example. I am going to create a list that contains 2 matrices in it. The first is a 2 by 2 matrix and the second is a 3 by 2 matrix. So you can see the list here. There's 2 elements. They are named A and B. Now suppose I want to extract the first column from each one of these matrices. So what I can do is I can call lapply. So there's no function out there that exactly extracts the first column of a matrix, but this is easy to do. You can just write a function that just takes the first column of that matrix. So here I'm going to call lapply on x, and I'm going to write the function right here. So I'm going to say function, and then I'm going to give it an argument, and then given that argument I extract the first column. So here when I call lapply with this function, I get the first column from A and the first column from B. So this function doesn't exist except within the context of lapply, and after the lapply function is finished, the function basically goes away. So that's an anonymous function because it doesn't have a name, and lapply and these other types of functions use anonymous functions very heavily, because unless there already exists a function that does the operation that you want to do, you are going to have to write the function kind of on the spot. So sapply is just a variant of lapply, and all it does is it tries to simplify the result of lapply if possible. So recall that lapply always returns a list, but sometimes you don't want a list. Sometimes you just want something different. So for example, if the result is a list where every element is a length 1, then what sapply will do is it will return a vector of all those elements. Usually you don't want a list where every element is a single number, for example. And so sapply will simplify that into just a vector if the result is a list where every element is a vector of the same length. If the list comes back and every element has a length 5, for example, then what sapply will do, it will put those elements in a matrix that's 5 by however long the list is. So that's often what you want to happen. But if it can't figure out how to simplify the object when it comes back, for example, if the object has many different types of things that comes back, then it's just going to do nothing. It will just return a list. So here in this example, when I called lapply and I applied the mean to everything, what happens is that I got a list back that's of length 4, and every element of the list is a single number. So it would be a lot nicer if I just got a vector back with all these numbers in it. And that's exactly what sapply does. So sapply called on x with the mean function gives me a vector with 4 numbers in it. Of course, if I called mean on the list by itself, that's not really going to work because main is not meant to be applied to lists, and so you will get a warning message with NA back. So that's it for today. See you in the next lecture where we will keep discussing other loop functions. So till then, read the material that is provided to you in the blog post and in the book, and practice what I give to you, because let alone watching these lectures won't make you programmer. You will have to practice to become a good programmer. And if you like my videos, then do share them and hit the like button and subscribe our channel so you don't miss on latest lectures. So see you in the next lecture. Ciao.